Now after completion the unit of periodic classification, we are our next unit, that is chemical bonding and the molecular structure. And before this unit we read about the structure of atom in detail and the position of the elements in the periodic table. Now we know a lot of things after the completion of the 3 units. Now we are on the chemical bonding and molecular structure. So chemical bonding lead to the molecular structure. When there is no chemical bonding, molecular structure cannot be possible. So we see various type of atoms around us which while bonding form our molecules, right? So the molecules can be of different type, and these are homonuclear diatomic molecule. So here the word homo means same and di means two molecules. So homonuclear diatomic molecules means in which a molecule is formed by a joining of two atoms and which are similar. For example, we can take that hydrogen, fluorine, oxygen, etc. Okay. Second is heteronuclear diatomic molecule. In this also two atoms are there, but here they are different. So we can take HBr, HCl, HF. These are the example of hetero. Hetero means different. Okay. Next is homonuclear polyatomic. So homo means same, poly means what? More than two, and atomic molecule. So in which हमारे एटम्स तो सेम ही रहेंगे, लेकिन वो अभी पॉली एटमिक फॉर्म में होंगे. फॉर एग्जांपल लाइक P4S8. ओके, these are the example, or ozone also, O3 are the example of polyatomic molecule. And the last one is heteronuclear. In heteronuclear polyatomic molecules, there are a number of atoms more than two, but they all are different to each other. For example, like HNO3, right, and H2SO4. Okay, and we can take what, CH3Cl, like etc. Okay, these are the heteronuclear polyatomic atoms. Okay, now we will see that what is chemical bonding. So chemical bonds are the attraction forces between the different chemical species which bind them together. Different chemical species को एक साथ जोड़े रखने के लिए जो फोर्स ऑफ अट्रैक्शन काम करता है उसी को हम क्या बोलते हैं? उसको हम केमिकल बॉन्ड बोलते हैं. केमिकल बॉन्ड्स आर ऑफ डिफरेंट टाइप, वी विल सी लेटर. And before going to the bonds, type of bonds, we will first see the Lewis concept and the Cauchy concept. Okay, so we will go for the next topic now. Now here is the scientist Cauchy Lewis approach to chemical bonding. So they took several attempts, and at last they succeeded, and in 1916 they just explained the stability of the inert gases. So they explained the stability of inert gases. Okay, we know that what are inert gases? They are unreactive gases, because an atom will be reactive till it does not gain the stability. जब तक कोई एटम स्टेबिलिटी को गेन नहीं करता है तब तक वो रिएक्टिव रहता है, और वो स्टेबिलिटी को गेन करता कब है? when it has its outer most shell completed by 8 electrons. जब उसके outer most shell में 8 electrons होते हैं तब वो स्टेबल हो जाता है. तो नंबर ऑफ एटम्स आर ट्राई टू बी स्टेबल, वो स्टेबल होना चाहते हैं, इसी वजह से वो केमिकल बॉन्डिंग करते हैं. तो स्टेबिलिटी ऑफ इनर्ट गैसेस जो कॉसल एंड लुइस ने एक्सप्लेन किया, उन्होंने ये बताया कि इनर गैसेस इतनी स्टेबल इसलिए होती हैं बिकॉज दे हैव देयर आउटर शेल फिल्ड विद 8 इलेक्ट्रॉन्स एंड स्टेट ऑफ ऑक्टेट इज acquired or achieved. Now we know that what is valence shell. We know what is valence shell and what is valence electron. So the valence shell is a outermost shell of an atom and valence electron is an electron which is present in that outermost shell. Suppose here is an atom of sodium, right, of sodium. So here 2 electron, here 8 and here 1 electron because its atomic number is 11. So this shell is outermost shell and it is known as the valence shell, and the electron present in this shell is known as the valence electron. And we know that in chemical bonding inner electron does not take part. valence shell से जो अंदर वाले इलेक्ट्रॉन होते हैं वो कोई भी पार्टिसिपेशन नहीं करते हैं केमिकल बॉन्डिंग में. ओनली द वैलेंस इलेक्ट्रॉन टेक पार्ट इन द केमिकल बॉन्डिंग. ओके, तो हमें ये पता है. नाउ नेक्स्ट, द लुइस ऑल्सो इंट्रोड्यूस अ न्यू टर्म फॉर अ एटम. उन्होंने पॉजिटिवली चार्ज्ड एटम्स को कर्नल कहा. What he said, उन्होंने बोला कि पॉजिटिवली चार्ज एटम्स को हम कर्नल भी कह सकते हैं. फॉर एग्जाम्पल, सपोज here example of sodium. Now we will call it kernel, and what it include? It include the nucleus plus inner shell electron and positive charge on it. So means here is now what is left behind? Only one electron is left behind in a sodium according to the configuration. So this electron will be shown by like this. Okay, in the same way magnesium also. So magnesium will call a kernel when it has electron like this, because it has 2 valence electron in outermost shell. So the Lewis introduced a new term kernel for the positively charged atoms. Okay, because they will lose the electron and will get the positive charge. Right, now we will talk about the Lewis symbol, which show as a kernels, and we are taking the example of second period, and you can take the example of other period also. So now we will see that here the second period start from lithium ions on neon, and the number of electron in outermost shell are here 1, 2, 3, 4, 5, 6, 7, 8. So according to the Lewis symbol, the elements or atoms can be represented by in this pattern. These are all kernels, and the benefit of such type of structure is that by seeing only the Lewis symbols, we can easily find out that which element or atom has how much valence electron in its outermost shell. तो इसका बेनिफिट ये है कि इसको देखकर ही पता चल जाएगा, अगर हमको ऐसे मिल जाता है लुइस सिंबल लिखे हुए, कि किस एटम के आउटर मोस्ट शेल में, वैलेंस शेल में कितने इलेक्ट्रॉन्स प्रेजेंट हैं, और वो ऑक्टेट स्टेट को अटेन करने के लिए आउटर मोस्ट शेल में 8 इलेक्ट्रॉन को फिल करने के लिए, स्टेबिलिटी अटेन करने के लिए नंबर ऑफ इलेक्ट्रॉन्स को यूज करने वाला है, या फिर नंबर ऑफ इलेक्ट्रॉन्स को गेन करने वाला है. इसी कंटिन्यूएशन में केमिकल बॉन्डिंग की जो कॉन्शियल साइंटिस्ट थे, उन्होंने अपने कुछ फैक्ट को रिवील किया. जिसमें he said that the very first that in a periodic table when there are alkali metals according to Causal उसने ये बोला, he said that these are highly electropositive and he said that the halogens are highly electronegative, and he said that in between the highly electropositive alkali metal and highly electronegative halogens there are noble gases. It is this concept is according to the Causal. Further he said that when alkali metal form positive ion by losing the electrons and halogens forms the negative ion by gaining the electron, both by doing this attain the stability. जब alkali metal electrons को lose करते हैं और positive ion बनाते हैं, halogen जब gain कर उसको negative ion बनाते हैं, तो ये ऐसा करते किस लिए? stability को attain करने के लिए. So the atom which loses electron, we know it is positively charged, called cation, and which gain the electron are negatively charged, are called anions. Okay, so we will understand it by taking example. Suppose we are having Na, so it forms positive charge by losing one electron of its outermost shell. Chlorine gains one electron and form negatively charged ion. Now how they react together? Na plus Cl. So it has 281, one electron extra. It has configuration 287. So this one extra electron will go to the calcium. Now it has sodium has 28 electron. Now it is stable now, and chlorine has 288 and it is also stable now. Now its formula is Na plus and Cl minus. Okay, so in this way they form the bonding. They just join together by this way. So we'll just see the bonding between the Na and Cl ions. Now here is a definition, that is the bond formed as a result of the electrostatic attraction between the positive and the negative ion was termed as the electrovalent bond. It is equal to the number of unit charge of the ion. So the bond which are formed between the two ions, that is we took the example of the Na and Cl. So it is a result of what? Electrostatic attraction and between positive and negative ions. Now this is was termed as the electrovalent bond, and it is equal to the number of unit charge on the ions. For example, Na has one positive charge, so it is positive electrovalence of 1. It has positive electrovalence of 1. Positive electrovalence of 1. Okay. If calcium has 2 positive charge, so it will be called positive electrovalence of 2. Now next, chlorine. It has 1 negative charge, so it will call negative electrovalence of 1. Okay, so how many charge an atom or ion will have on it? It will call it what? Electrovalence, right? So it is positive electrovalence of 1, positive electrovalence of 2, and negative electrovalence of 1. Now further, the Lewis and the Cossel in the same year 1916 gave a octet rule. They gave octet rule, and according to this rule, to attain the stability atom, the one way to attain the stability is the atom loses or gains electron, and the other way is that if they are not losing or gaining the electron, the other way is of the sharing of electrons. So these both methods are followed by the ions or atoms to achieve the octet configuration like a inert gases, and they will have the 8 electrons in their outermost shell. Okay. So after the explanation, I just wrote down this octet rule and so according to octet rule, atom can combine either by transfer of valence electrons or by sharing of valence electrons, as I have told you earlier also. In order to have an octet in their valence shell, this is known as the octet rule. So according to this rule, each atom is eager to have the 8 electron in its outermost shell. हर एटम अपने outermost shell में 8 इलेक्ट्रॉन चाहता है. क्यों? क्योंकि वो स्टेबिलिटी चाहता है. उसके लिए या तो वो शेयरिंग करेगा इलेक्ट्रॉन्स की, नहीं तो वो लूज और गेन करेगा. तो ये है हमारा ऑक्टेट रूल. आफ्टर दिस concepts, theories of the Cossel and Lewis. Next, the scientist came. He is Langmuir. Okay, so the Langmuir first introduced the term covalent bond. So the scientist Langmuir in 1919 introduced a term that is covalent bond. And covalent bonding is what? It is the sharing of electrons, and we can understand it by taking example. When an electron is used or gained by an atom, that is we just understood in the case of NaCl. So in such cases ionic bonds are formed because ions formed, and in this case when covalent bonding takes place, only sharing of electron takes place. No one going to give electrons permanently to the other. So we will understand it in case of chlorine. Okay, so how the formation of chlorine atom takes place. We know that chlorine have found in atmosphere in diatomic form, and it is homonuclear diatomic form. Here we know that configuration is 287. It has 1, 2, 3, 4, 5, 6 and 7 electron in outermost shell, and in the same way this is also 1, 2, 3, 4, 5, 6. Now what we do to complete its octet, how much electron it want? Both the chlorine want one electron they want. So it is not going to give the 1 electron permanently to this atom, and this one is also not going to give the 1 electron permanent to this chlorine. So what will happen? They will go for sharing. So how much electron they will share? So they need only one electron. So one of its electron it will share. So it will give to this chlorine atom, and this will also share 1 electron of its. So this 1 electron shared by this chlorine, and this one is shared by this chlorine. Okay, so here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now both the chlorine have 8 electron in their outermost shell, and they achieved the state of octet, and both are stable now. Okay, So it is a single covalent bond because here is a sharing of two electrons is taking place. So it is a single covalent bond. Now we will see that the types of covalent bond. So covalent bonds are single, as we saw in case of the chlorine, and they can be also multiple bonds, multiple covalent bond and single covalent bond. Okay, so multiple covalent bond can be further of two types, that is double bond and triple bond. Okay, so double covalent bond and triple covalent bond. Now we will see how they will form. So double bond will be formed by, suppose oxygen. We will take the example of oxygen. Okay, so oxygen has 2 6, तो it need 2 electron. तो ये एक ऑक्सीजन एटम, दूसरा ये, so 6 electron outer motion. How much electron they need to complete octet? 2 electrons. So if they need 2 electron, it means the sharing will be of 2 electron by one oxygen atom. So 2 electron of this oxygen atom will be here, and 1 2 3 4. So 1 2 3 4 5 6 are of this oxygen. Now 2 electron of this oxygen. Now 1 2 3 4, and 1 2 3 4 5 6 of this oxygen atom. Now how this done? Okay, so 1 2 3 4 5 6 7 8 electrons this oxygen atom will have, and 1 2 3 4 5 6 7 8 electron this oxygen atom will have. And now both are stable by achieving the octet state, and sharing of 4 electrons or 2 pair of electron takes place here. So it is the example of double bond. So we can write it like oxygen is bonded by double bond with the other atom. Now here when we see the chlorine, so chlorine we can write it like this. Okay, for single bond. Now we will go for the triple bond. Okay, so triple bond we will see for we know that nitrogen atom, it has 2 5 configuration, N2. We will see the formation of N2. Okay, so what will happen? Now 2 nitrogen atom are here. So how much electron it need to be shared? 3 electrons. So 1 2 3 of this nitrogen, and 1 2 3 of this nitrogen. Now 2 electron it will have, 2 it will have. Now sharing will be like this. So 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, right? So it will be written like this. इसको ऐसे लिखा जाएगा, हम ऐसे बोल सकते हैं इसको. ठीक है, तो हमने देखा the covalent bonding in case of single bond, in case of double bond, in case of triple bond also. Now we will see what does these bonds are called. So in case of only single bond, अगर फर्स्ट सिंगल बॉन्ड है तो उसको हम बोलते हैं सिग्मा. ठीक है, सिग्मा बॉन्ड. तो इसका भी फर्स्ट अगर बॉन्ड ये है तो इसको हम सिग्मा बोलेंगे, और इसको भी हम सिग्मा बोलेंगे. नाउ द नेक्स्ट बॉन्ड्स आफ्टर द सिग्मा फॉर्म्ड आर कॉल्ड पाई बॉन्ड्स. तो ये पाई बॉन्ड, दिस इज ऑल्सो कॉल्ड पाई बॉन्ड, एंड दिस विल ऑल्सो पाई. ओके, वी आर sorry, 2 bonds are there. So it is sigma and pi bond. Here sigma, pi bond and pi bond. 3 bonds are there. Okay, so we understood that what is covalent bonding. Now in this chapter till here what we understood, we just understood the structure of the molecule and the bonding, and we know that around us we have the variety of molecules, because atom is not much stable except the inner gases. So they want stability, and for the stability they have to do sharing of electron, or they have to lose or gain electron to achieve the inert gas configuration. It means what? An atom can be stable by only attaining the 8 electron in outermost shell, And we also know that only the valence shell electrons takes part in the chemical bonding, and inner electron does not take part in the chemical bonding. Now Lewis introduced new term for the positively charged atom, that is kernel. And we also just saw the Lewis symbol, in which by watching the symbols we can easily find out that which atom have how many number of valence electron in their outermost shell. Then after Causel scientist, he also gave some fact about the chemical bonding, in which he said that in the highly electropositive alkali metals and highly negative halogens, there are the noble gases placed in between, and the alkali metals form the positive charge by losing the electrons, and halogen form the negative charge by the acceptance of the electrons. And we just see the formation of the ionic bond or electrovalent bond in case of the NaCl. And then Lanier came, and he just introduced the new term covalent bond in 1919. Covalent bond can be single and multiple bonds. Multiple bond can be of double and triple. And in covalent bond, only sharing of electron takes place. Now we see the types of bonds. So here the first bond is called or known as sigma, and next bonds come after sigma, known as pi bonds. Okay, now I think this much is so much for the first video. In next video we will do the next topics. Thank you so much.